5.4 Fundamental Counting Principle. Example 1 and number 1 from Eric Buffington's YouTube video titled Mathematics Counting Principles Simplifying Math. For more examples, you can refer to his videos if you like. Mary Beth has 3 types of bagels in the fridge, 2 types of cream cheese, and 3 veggies. If she wants one of each, how many different lunch options does she have? So let's say her different bagels types are plain, sesame, and cinnamon. And then her different types of cream cheese are strawberry or blueberry. And then she has either carrot, celery, or broccoli. So for one of her lunch options, she could choose the plain bagel with the strawberry cheese and then with the carrots. Or she could do plain bagel with strawberry cheese and then celery, or plain bagel, strawberry cheese, and broccoli. Right there, that's 3 different lunch options. Now she could choose the plain bagel with the blueberry cheese and then with the carrots, plain bagel with blueberry cheese and then with celery, plain bagel with blueberry cheese and then with broccoli. And then that is a total of 6 different lunch options. And then she could move down to the sesame bagel or choose a sesame bagel with the strawberry cheese and carrots and then so on. So basically, to find out all the different lunch options using this chart or this diagram, what you're going to do is just count up this last column. And the total in the last column is 18 lunch options. So let me go ahead and box that here. So a total of 18 different lunch options. Now, it's not always a practical idea to use a chart like this, especially when your numbers get larger. Like if you had 15 different bagels and 5 different cream cheeses, then your chart would be really huge. So a better thing to do is to just use the fundamental counting principle, which I will demonstrate here. So for the first slot, that will represent the bagels. And then for the middle slot here, that's the cream cheese. And then for the last slot, we'll have the veggies. All right, so for the bagels, she has 3 different types, and cream cheese, she has 2 different types, and then veggies 3. So all you do is just multiply these together. So 3 times 2 gives you 6, and then 6 times 3 gives you 18, and then you have your answer right away. So 18 lunch options. So this is the more practical way to find all your different options. And this is called the fundamental counting principle. How many different outfits can Jim wear? Jim has 3 pairs of pants, 2 shirts, and 2 hats. How many different ways can he dress? So let's say his pants are jeans and he has blue jeans, dark blue jeans, and black jeans. And then his shirt is either red or white. And I didn't put the hats here. Let's say they're just baseball hats. And we'll just call that hat 1, hat 2. I'm not sure what color his hats are. It doesn't really matter. Usually baseball hats go with pretty much anything, but of course he could have a cowboy hat, you know, whatever type of hat. Whoops, that's supposed to be a 1. Let me fix that. Okay, so for one of his different outfits, he could have the blue jeans with the red shirt and then baseball hat 1, or the blue jeans with the red hat, or excuse me, red shirt and then hat 2, or he could have his blue jeans with the white shirt and hat 1, blue jeans with the white shirt and hat 2. So right there, that's 4 different outfits. Or he could choose his dark blue jeans with his red shirt and his hat 1, dark blue jeans with his white shirt, or excuse me, red shirt and then hat 2. So basically, again, when you have this chart here, you're just going to count up the last column here. So he's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different outfits. He has 12 outfits he could choose from. Now, a faster way to do this is just use the fundamental counting principle. So we'll just make slots right here. So this would be his pants or his jeans, his shirts, and then hats. So he has 3 different types of jeans or pants to choose from, and then 2 different shirts, and then 2 different hats. So 3 times 2 gives you 6, times 2 more gives you 12. So he has a total of 12 different outfits that he could choose from. All right, for example 5, or excuse me, example 2, there's 5 college friends that are going on a road trip together for spring break. How many ways can they seat themselves in a 5-seat car? Use factorial notation. So let's just use a little diagram here, I guess, to represent the seats in the car. So say you're looking at the car from above. This would be the driver's seat, this would be the passenger seat, and in the back we have the 3 seats in the back. So we're assuming that all of these people can drive. So we have 5 different people to choose from for the driver, and then that would leave 4 people to sit in the passenger seat, and then 3 people to sit in this seat, and then 2, then 1. So basically, what we can do is just use the fundamental counting principle and just multiply these all together. So for the first one of the seats, we have 5 people to choose from, and then 4 people, and then 3, and 2, then 1. That'll give us all the different ways they can sit in the car, and that is a total of 120. Now, what you can do is use what's called factorial. This exclamation mark is called the factorial button or key or notation, factorial notation. You can find it on the calculator by going to your math button here, right there. And then you're just going to arrow over to this stands for probability, and then arrow down to number 4, and then you'll have the exclamation mark, which represents factorial. And all this is what's happening is your number is just decreasing by 1. So whatever number is in front of your exclamation mark, you put that there and decrease it by 1, decrease it by 1, and then decrease by 1. Keep decreasing it down to 1. And so that's just a faster way to figure that out, and other than putting in the calculator 5 times 4 times 3 times 2 times 1. In general, if you start out with n, then you would have whatever number here, which would be your n, and then you decrease by 1. But if you're always starting with n, then you'd have to decrease by 2, and then decrease by 3, and then so forth down to 3, 2, 1. Let's go ahead and see what the next problem is here. So for example 3, suppose that 10 unique names are put into a hat and drawn at random without replacement. So that's important because our answer would change if they did replace the names. How many different ways can you draw all of the names from the hat? Remember, without replacement means that the names are not returned to the hat after they are chosen. Write your answer in factorial notation. Okay, so for the first draw, we have 10 names to choose from. Then the second time they draw a name, there will only be 9 in there, and then 8, and then 7, and then 6, and etc. So basically, we're just going to multiply these dot, dot, dot down to 3, 2, 1. Now you can put that in your calculator, 10 times 9 times 8 times 7 times 6. That gets kind of tedious and cumbersome. So a better or faster way to do that is just use your factorial button. That's what that factorial button means, is whatever number you put in front of it, that's just decreasing by 1 each time all the way down to 1. So if you put that into your calculator, you're actually getting this really big number. It's 3,628,800. So there are 3,628,800 different ways that you can choose 10 names out of a hat. And for your homework, they just want you to leave it in factorial form, so you could just put 10 factorial.